I'm using Scikit-learn's FastICA, a popular algorithm for independent component analysis. The WHITEN parameter is a key setting that I need to understand. It controls a pre-processing step that can significantly affect the results. I'm working with a dataset containing 100 data points, each described by 5 features. This is the input data that I will feed into the FastICA algorithm. FastICA is short for Fast Independent Component Analysis. It's a specific implementation of the ICA algorithm within the popular Python machine learning library, Scikit-learn. If I set WHITEN to TRUE, the algorithm preprocesses the data to have 0 mean and unit variance equal to 1, in each feature. This results in independent components also having unit variance. Setting WHITEN to FALSE skips this preprocessing step. This speeds up computation, but the resulting independent components will likely have different variances. The WHITEN parameter's main focus is on variance, not orthogonality, meaning the components are uncorrelated. While it might have a slight indirect effect, I can't rely on it for controlling orthogonality. Orthogonality isn't the primary goal of ICA. The impact of the WHITEN parameter on interpretation depends entirely on the specific dataset. It's not something that is universally significant. These are the outputs of the FastICA algorithm. They represent the underlying statistically independent sources that were mixed together in the original data. Whitening is a data preprocessing technique. It's like preparing your ingredients before you start cooking. In this case, it centers the data around 0 mean and scales each feature to have unit variance. I'm looking at the FastICA algorithm in Scikit-learn, and I'm focusing on its WHITEN parameter. This parameter controls a preprocessing step before the main ICA, independent component analysis, calculation. I'm working with a dataset that has 100 data points, each described by 5 different features. This is the data that FastICA will be applied to. When I set WHITEN to TRUE, I'm telling the algorithm to first standardize my data. This means that the data will be centered around 0 mean, and each feature will have a variance of 1. This standardization step affects the final independent components. If I set WHITEN to FALSE, I'm skipping the data standardization. The algorithm will process the data as it is, with whatever means and variances it has. This often makes the calculation faster, but the resulting independent components might not have unit variance. I guarantee that my independent components will have a variance of 1 unit variance. This is because of the data preprocessing step. If I choose, the computation will generally be faster, but the resulting independent components will likely have different variances. The WHITEN parameter's main effect isn't on orthogonality, meaning whether the components are uncorrelated. While it may have a secondary, indirect effect, it isn't the primary goal. Whether or FALSE significantly changes the interpretation depends heavily on the specific dataset. It's not universally impactful. I see that you're working with Scikit-learn's FastICA algorithm, which is used for independent component analysis, ICA. The WHITEN parameter is key here. It controls a pre-processing step. Think of it like preparing your ingredients before you start cooking. It affects the final outcome. We have 100 data points, each described by 5 different characteristics or features. This is our raw data that FastICA will process. Let's figure out which statements about WHITEN parameter are correct. This parameter is all about how we prepare our data before performing ICA. When FastICA first standardizes the data so each feature has a mean of 0 and a variance of 1. This ensures the resulting independent components will also have a variance of 1. It's like making sure all your ingredients are equally potent before mixing them. If we skip the standardization step, that speeds things up, but the resulting independent components will likely have different variances. It's like using ingredients directly without any preparation, resulting in varying intensities in the final dish. I would say that while whitening might indirectly affect the orthogonality, meaning the independent components are uncorrelated, it's not its primary goal. FastICA's main goal is to find statistically independent components, not necessarily strictly orthogonal ones. It's important to understand that difference. The impact of WHITEN on interpretation really depends on the specific dataset you are using. It is not a universally significant factor. Sometimes it will matter, sometimes it won't. It's like adding a pinch of salt. Sometimes it makes a huge difference, sometimes it's barely noticeable. This is the title of the quiz question. The quiz focuses on understanding how the WHITEN parameter in the FastICA algorithm, a method for independent component analysis, affects the results. I'll explain the parameter and its effects step by step. The problem involves using SCIKITLEARN's FastICA, a popular machine learning library's implementation of the FastICA algorithm, to analyze a dataset with 100 samples, rows, and 5 features, columns. When you set, FastICA preprocesses the data to have 0 mean and unit variance of 1, along each dimension. This preprocessing step guarantees that the resulting independent components will also have unit variance. If you set, you skip the data preprocessing step, and the original variances are retained. The resulting independent components will then likely have different variances. Skipping this step generally speeds up computation. The statement is false. Although the whitening process might indirectly influence the orthogonality, meaning that the resulting components are uncorrelated, the primary goal of ICA is statistical independence, not strict orthogonality. FastICA does not guarantee perfectly orthogonal components. This statement is also false. The effect of whitening on the interpretation of the results greatly depends on the specific dataset. In some cases, the impact may be insignificant, while in others it can be substantial. This is the parameter in question. It controls whether FastICA performs a preprocessing step called whitening, affecting the variances and potentially the interpretation of the independent components. It's a binary choice. You set it to either TRUE or FALSE. I'm using scikit-learn's FastICA, a popular algorithm for independent component analysis. It helps me uncover hidden independent signals from a mixture. Think of it like separating the voices of different instruments in a musical recording. This parameter in FastICA is a preprocessing step. It's like preparing your ingredients before you start cooking. Setting it to true or false significantly changes how the algorithm processes the data. When I set "whiten equals true", I activate a data preprocessing step called whitening. Whitening ensures that each feature, or dimension, in my dataset has 0 mean and unit variance equal to 1. This standardization makes it easier for FastICA to find the independent components. Imagine it like leveling a playing field, so that all features are on an even footing. If I set "whiten equals false", I skip the whitening step. This means that FastICA works directly with the data's original variances. This might be faster but could result in the independent components having different variances. It's like cooking without properly prepping. You might still get a result, but it might not be optimal. With "whiten equals true", I get independent components that all have unit variance equals 1. It's a nice, consistent output, making interpretation a bit simpler. When "whiten equals false", I obtain independent components, but their variances will vary. Each component might have a different level of dispersion or spread around its mean. This can make it more challenging to interpret the results. This statement is true. The whitening preprocessing step ensures that. This statement is also true. Skipping whitening saves computational time. This is generally false. While there might be some indirect effects, FastICA's primary focus is on statistical independence, not perfect orthogonality, uncorrelatedness. This is false. The impact on interpretation is data-dependent, so it's not universally significant. I'm using the FastICA algorithm, and the "whiten" parameter is key. It controls whether data is preprocessed to have a mean of 0 and a standard deviation of 1 before the algorithm starts. Think of it like preparing ingredients before cooking. Some recipes call for specific prep work, others don't. These are the hidden signals that FastICA tries to uncover. Think of it like separating the different instruments, like drums, bass, guitar, from a mixed recording. Each instrument is a separate, independent component. If I set "whiten equals true", I guarantee each independent component will have a variance of 1. This is because the data is pre-processed to have this property. That's a nice, standardized result. Setting "whiten equals false" skips the pre-processing step, making the computation quicker. However, it means the resulting components might have different variances. Think of it as a trade-off between speed and standardized output. This statement is a bit misleading. While whitening might indirectly affect orthogonality, meaning the components are uncorrelated, FastICA's primary goal is statistical independence, not perfectly orthogonal components. This isn't always true. The impact depends on the data itself. Sometimes the difference is tiny, and other times it's significant. There's no one-size-fits-all answer here. This pre-processing step ensures that each feature in the data has a mean of 0 and a standard deviation of 1. This simply means each independent component has a variance of 1. Variance measures how spread out the data is. This skips the pre-processing step described above, so features retain their original variances. This means that the resulting independent components will likely have different variances. Some will be more spread out than others. I'm using Sklearn's FastICA, a popular algorithm for independent component analysis, ICA, to analyze a dataset. This dataset has 100 samples and 5 features. I'm focusing on the "whiten" parameter and exploring how different settings affect the results. That's important because ICA aims to uncover hidden independent sources from mixed signals. Think of it like separating different musical instruments in a recording to isolate each instrument's sound. My dataset contains 100 different observations, samples, and each observation is described by 5 different characteristics, features. For example, if I'm studying different types of fruits, each sample could be a particular fruit and the features could be things like weight, color, sweetness, size, and texture. FastICA is the algorithm I use to perform the ICA. It is a well-known method for separating mixed signals into their statistically independent components. The algorithm works by iteratively transforming the data, aiming for independence among the resulting components. Before applying FastICA, I can choose to pre-process the data using a whitening process. Whitening centers the data around 0 mean and scales each feature to have unit variance. This means making the average value of each feature 0 and ensuring that the spread or variability of each feature is the same. This pre-processing step is controlled by the "whiten" parameter. If I set "whiten equals true", I explicitly tell FastICA to whiten the data first. This guarantees that the independent components I get will all have unit variance, a variance of 1, meaning they all have the same amount of spread. If I set "whiten equals false", then the data's original variances are preserved. The FastICA algorithm will proceed without the pre-whitening step, which might lead to slightly faster calculations, but it is important to note that the resulting independent components will likely exhibit different variances. I want to mention that while whitening might have a minor influence on the orthogonality, uncorrelatedness, of the resulting components, it is not its main purpose. Orthogonality is not the primary goal of ICA, statistical independence is. FastICA doesn't guarantee perfectly orthogonal components either way. The effect of choosing "whiten equals true" or "whiten equals false" on how I interpret the results strongly depends on the dataset. Sometimes the difference is tiny, other times it's significant. It is not a universally significant change.